Hello everyone, my name is Purva Dongre. Today I am presenting assignment 2 for SIT 718 Real World Analytics. My topic is using aggregation functions for data analysis. Over the next few minutes, I will explain the dataset, models, and the results. In this presentation, I will show how the weighted aggregation functions are applied to analyze the wine quality. The discussions will also walk you through the data analysis workflow supported by the histograms and the scatter plots, highlighting the different transformation techniques, model building, and prediction results for the insights. The dataset has 4,899 samples of white wine in the CSV format. Input variables include the fixed acidity, volatile acidity, residual sugar, free sulfur dioxide, total sulfur dioxide, and the alcohol. The target variable is the wine quality, which is Y. Understanding the dataset is the first step before modeling. Understanding the data for the X1 fixed acidity, the scatter plots here shows a moderate positive relationship with the quality, and the histogram distribution is asymmetric. A few outliers show a very high or very low acidity values. What's the next is the understanding of the data for X2, that is the volatile acidity. Volatile acidity negatively impacts the quality. Here the scatter plot shows the higher values, which leads to a lower wine scores. The histogram is right skewed, which most of the wines at low levels. Outliers with the high acidity correspond to very poor quality of the wine. Coming towards the next slide is understanding of the data for X3, that is the residual sugar. Here the scatter plot shows a very weak relation with the wine quality, as we can see that the points are scattered. The histogram is a right scale distribution, as most of the wines have a low sugar and few have the high sugar level. The outliers are extremely high for the sugar levels. Understanding the data for X4, that is the free sulfur dioxide. Here, the scatter plot shows a weak positive relationship with the wine quality. The outliers are the some wines have very large levels of SO2 levels, whereas the histogram shows us a distribution which is a right skewed. The next is the X5, that is the total sulfur dioxide. Here, the scatter plot shows a very weak relation with the wine quality, and the histogram here is a symmetric histogram, as most of the wines have similar values. The outliers here are high total in few samples. Coming towards the next is the last, that is the X6, that is the alcohol. Here the scatter plot is the moderate positive relationship with the wine quality. Higher alcohol content generally associated with the higher quality. Here the histogram is slightly left skewed. Also, the scatter plot confirms the strain. Alcohol is one of the most significant predictors. In data transformation, we normalize the selected predictor and the target variable to ensure that they are lie on the same scale. The normalization ensures all the variables contribute equally to the model, which helps to improve its performance and prevent a large-scale features from dominating. Aggregation and the model fitting. The goal here is to predict the wine quality using the selected four variables, that is the X1, X2, X4, and the X6. The model used here are WAM, WPM, and the OWA. The WAM, that is the weighted arithmetic mean. The main aim of the WAM is to combine all the features linearly using the weights. The WPM, it emphasizes the smaller or the larger values depending on the value of the probability. The OWA, that is the ordered weighted averaging, it sorts the features first and then applies the weight. The main purpose of OWA is to capture the optimistic versus the pessimistic contributions of the variables. Coming towards the next is the script use. So we have used aggregation WA fit 718R to fit the model WAM, WPM, and the OWA. Here, the significance of the output is understanding of the model fitting and aggregation is very necessary, as it helps to identify the most accurate model for predicting the wine quality, which guides the decisions on which the features to focus on to improve the wine quality. Coming towards the next slide, that is the model weights for the prediction. It helps us to identify the key points and the guides quality improvement strategies based on the aggregation methods. Higher the value of the weight indicates greater the influence on the wine quality predictions. X1, that is the fixed acidity, and X4, that is the free sulfur dioxide, are the most significant predictors. Model comparisons reveals how different aggregation methods prioritize the features. Coming towards the next slide is the prediction for the new sample. We predicted the quality of a new wine sample using our selected variables that were x1, x2, x4, x6 across the models. This allows us to compare how each model interprets the data and assess which provides the most reliable prediction. So the model and the predicted quality are the given below, such as WAM gave the 9 predicted quality, WAM with the probability of 0.5 gave 9 predicted quality, WPM with the probability of the 2, it gives predicted quality as 7, and the ordered weight averaging gives a predicted quality of the 7. The purpose for the clip and the denormalizing prediction is to ensure that the prediction remains within the range of 0 to 1. So here I have performed the transforming of the normalized values back to original wine quality. The next slide is the predicting all the samples. So computation predictions for all the normalized data, we have used the function predict all. Here the model applies are WAM, WPM with the probability of 0.5, WPM with the probability of 2, and OWA. The functions used in this are P minimum and P maximum that ensures the prediction stays between 0 and 1, and also the normalization function which helps in the scaling to keep the consistency of the features. The next slide is the model performance matrix. RMSE, that is the root mean square error and absolute error for aggregation models. So the RMSE, it is used to measure the average difference between the predicted and the actual values, showing how well the model fits the data. Lower root mean square error means the model predictions are closer to the reality. The absolute error, it shows the average size of the prediction errors without considering the directions. Lower the value of absolute error means more accurate is the predictions. This is the slide for the table for RMSE and the absolute error values. Summary and the key insights. Best fitting model WPM with the probability of the 2 shows a best fitting model as it has a lowest RMSE value about 1.30 and absolute error which was about the value 1.05, making it more reliable for predicting the wine quality. This model captures the data patterns more accurately than the previously used data models which were WAM, WPM with the probability of 0.5 or and the OWA. The practical implications. Winemakers can use these insights to monitor and adjust the key parameters to achieve the higher quality wines. The model also balances accuracy and making it suitable for the real world decision makings. The limitations and the ethics. The model's accuracy depends on the features selected and the data size. While it provides a useful predictions, some complex patterns may be missed, so results should always be validated before making any decisions. It is important to maintain a data privacy and the use of the insights responsibility.